Good evening. Today we're going to be finding absolute maximums and minimums. This is the video following up the one about critical numbers and the concept of maxims and mins in general. This one's going to be more mechanical. I'm just going to go through several functions and find the maxes and the mins through the first derivative. So the first one I'm going to pick is a harmless looking quadratic. Negative x squared plus 5x minus 4. And I'm limiting the domain to 0 to 5. So we're only looking for the maximum, absolute max and mins in this interval. Nothing beyond 5, no 0. And if you know what this shape looks like, then you'll know why I'm putting that restriction in the function. So we go for the first derivative first, because the first derivative will give us the slope function. And since I'm looking for absolute maximums and minimums, I am now going to set the slope function to 0, because that's where I'm going to find maxes and mins. And when I set it equal to 0, x will equal 5 over 2, or 2.5. Now, this is not the only critical number that I have to check. I have to check the 0 and the 5, because it is possible that the critical numbers at the beginning and end of this interval, those could actually be my absolute max or my absolute min. So I'm going to calculate f of 0, f of 5 over 2, and f of 5. And f of 0 will be negative 4. F of 5 over 2 is going to be negative 25 over 4 plus 25 over 2 minus 4. And that's 25 over 4 minus 16 over 4, and that's 9 over 4. So far, f of 0, negative 4, that's a candidate for absolute min, and this is a candidate for absolute max. But it all depends on what I get for f of 5. And that is negative 4 as well. So I actually have two absolute mins, since they have the same y value. So there is an absolute min at 0, and there's an absolute min at 5. And then there's a max, absolute max at 9 over 4. And if you know what this looks like, this makes perfect sense. Because this will be an upside down parabola. And if this is 5 over 2, that's going to be my max. And since it's upside down, it's going to go down like this, and it's going to go down like this. And these are my two mins on this interval. This will be 5, negative 4. This is 0, negative 4. And then my max is over here. Okay, so this graph gives you an idea of what are we actually finding? How is this helping us? Yes, I realize you could probably graph this in a more Algebra 1 kind of method. But calculus allows you to graph simple things like that too. Okay, second one we have here is f of x equals rad of 1 plus x, and we're going to stay within the interval of -1 to 8. First I'm going to rewrite this in exponential form so that we can use the power rule. So using the power rule, the first derivative is 1/2 1 plus x to the -1/2 power. And now I set that equal to 0. And I'm going to rewrite this in fraction form. And there it is. Now, something interesting here. This fraction actually can never be 0 because the numerator is 1. So I'm not going to get a critical number from this expression. So the only critical numbers I have to test are -1 and 8 from my interval. So since there's no critical number in between -1 and 8, that means one of these will be the max and the other one is going to be the min. Okay, this function is a lot easier to work with than the previous one. That's going to give me 0, and then this is what's going to tell me what's what. I put 8 in and I will get 3. So this is my min and this is my max. Okay, so in this case the derivative didn't give me any critical numbers, and the min and the max just came from the endpoints of the interval itself. Okay, third one, we're going to go back to a polynomial. And we'll be on the interval of -5 to 4. Nothing fancy here, just power rule. Setting it equal to 0 and taking out a 3. And that is factorable. So I will get two critical numbers, -3 and 1. So I have 4 numbers to test, the -3 and 1, and my 2 endpoints. So putting these in order from least to greatest. And now plugging in, -5, negative and negative makes positive. That will be -5. Plugging in -3 now. Negative, negative again. Makes positive. So that could be my max. We'll see. Uh, 4 minus 9, that's -5. Ooh, I might have a double min. We'll see. The last one will tell us. Doesn't look like I'm going to get a new min here. So this is 112 minus 36, 76. So that's my max. This is my max. Min, min. And that'll probably be a local max, but this is my absolute max right there. So judging by the information here, this function probably looks something like this. Something like that. So I've got my two mins here and then my max up there. And there's a local max here. Alright, now we're on to fourth example. This one's going to have a little trig in it. Always got to include some functions with trig, because you don't want to forget your derivatives of trig ratios. Okay, so first derivative of sine is cosine. Derivative of cosine is negative sine, so that'll turn it into plus. Now I set this to 0. Okay, so we got to think about this. If the sum of cosine and sine is 0, that must mean the cosine and sine of whatever angle this is, they are opposites of each other, meaning negatives of each other. Where does that happen? So that only happens here and here. So that's 3 pi over 4 and 7 pi over 4 in the 45, 45, 90 degree triangles there. The cosine and sine are exact negatives of each other. Here the sine is rad 2 over 2, the cosine is negative rad 2 over 2. Here the cosine is rad 2 over 2 and the sine is negative rad 2 over 2. However, I don't have to worry about this triangle in quadrant 4 because my interval is from 0 to pi. So I only have to keep 3 pi over 4. So I have three values to test: 0, 3 pi over 4, and pi. If I plug 0 in here, I get 0 minus 1, and that's negative 1. 3 pi over 4 here, rad 2 over 2, minus negative rad 2 over 2, which is rad 2. And pi is 0 minus negative 1, that's 1. So I have an absolute max here, an absolute min here, and not sure about that. It can't be a max or a min, because then I would need another max or a min. So this might be, it might be an inflection point, but that's for another video. Okay, and we've got one more. This is a polynomial degree 4 and no interval. No interval. Okay, setting the first derivative to 0. And I'm going to go ahead and start factoring this. I'm going to take out 12x. And this is x minus 2, x plus 1. So I've got 3 critical values here, 0, 2, negative 1. Alright, at f of negative 1, I have 3 plus 4 minus 12, that is negative 5. At 0, I have 0. At 2, I have 48 minus 32 minus 48, that is negative 32. So it looks like I have a min here and a max here, at least on the interval from negative 1 to 2. That is what I have, a max at 2 and a min at 2 and a max at 0. And the reason I have to introduce this interval here is because I know what this looks like. It's a function that has this kind of shape. So the f of 2 with the negative 32, that must be this right here. So that's got to be lower than that. So it's probably something like this. Forget about that. It's probably something more like this. This is the min, and then my max is at f of 0, probably something like that. And then this is a local min. But I had to put the interval there because this is a function that is a W-shaped thing that goes on forever. So if I don't put the interval there from here to here, then you can see what, as the arrows say, there is no max. There is a min, but no max. Okay, so that's finding absolute maxes and mins using first derivative. Thanks for watching K109 Math, and we'll see you later.